Alright, so in this video we're going to go over vector addition, subtraction, multiplication, division, and how to find the magnitude of a vector. Alright, so let's start out with addition and subtraction for vectors. Alright, so vector addition is fairly straightforward. If we wanted to add the vector 2, 4 to the vector negative 6, 5, okay, all you're going to do is add the x's, okay, and then you're going to add the y's. That's it. So 2 plus negative 6, or 2 minus 6, that will give you the new a term, and then 4 plus 5 will give you the new b term. So this comes out to negative 4, 9. Okay? Now, what does that look like graphically? Alright, so what does this look like graphically? So we have vector 2, 4. So if we pick this as our starting point, we're going to go over 2, up 4. 1, 2, 3, 4. So that's going to be the terminal point for our first vector, 2, 4. Now let's look at our next one. Negative 6, positive 5. So we go over, so that's 2, 3, 4, 5, 6, and then up 5. 1, 2, 3, 4, 5. So that is going to be the terminal point of negative 6, 5. Oops, I don't know why that random vector just appeared there. Let me get rid of it. Alright, so this negative 4, 9 is the vector from this initial point to this terminal point. Okay, because remember, this was vector 2, 4 right here. And then this was vector negative 6, 5. Okay, so the vector negative 4, 9, which we got when we added these two together, would be this vector right here. And that is called your resultant vector. Okay? That's your resultant vector. So I can spell vector. Alright, so that's your resultant. Alright. So for all you do for addition of vectors is you add the x's and you add the y's. That is it. Subtraction is the same way. Alright, for subtraction, you subtract the x's and subtract the y's. Alright, so if we have the same vector, alright, and we wanted to subtract these, we're going to do 2 minus negative 6, 4 minus 5. Okay, so that's going to go to a positive, so this is going to be 8, negative 1. Alright, so that's all there is to adding and subtracting vectors. If we had it in the linear combination format, you're simply going to add or subtract the i's and add or subtract the j's. So for instance, if we had 3i minus 2j, and we wanted to add to that 7i plus 4j, you'd simply add 3 and 7 and get 10i. And then you'd add the negative 2 and the negative 4 to get plus 2j. Okay? Subtraction, if this was subtraction, you would have subtracted them and gotten a negative 4. And then here you would have gotten a negative 6. Okay? So that's really all there is to adding and subtracting. You add the x's or the a's, however you want to look at it, and then you add the y's or the b's. And that's it. Then you just write what's left as a vector. Alright, let's go into multiplication and division. Alright, multiplication and division. Well, I got a little bit of good news for you. We never actually multiply vectors. Okay? Well, let's preface that with kind of. Never multiply vectors. But we can multiply by a number. Okay, we can multiply a vector by a number. And that number is called a scalar. Okay, that number is called a scalar. So let's look at, say we want to take the vector 2, 4, and we want to multiply it by 2. Basically, all you're going to do is you're going to use distributive property, and you're just going to distribute the 2 through. So this would come out as 4, 8. All right, if we were in linear combination format, this would be 2i plus 4j, and we wanted to multiply that by 2. Same process. You just distribute this through, so you'd get 4i plus 8j. And that's it. That's it for multiplication. That's all you're going to do for multiplication. So you're going to take a number, which is called a scalar, and just distribute it through your vector. Whichever format it's written in, you're just going to distribute it through your vector, and that is all. All right, now division. If we wanted to divide a vector by a number, all right, you're just simply going to divide your first one, your a term, so 8 divided by 2 is 4, 6 divided by 2 is 3. That's it. Because if you think about it, dividing by 2 is the same thing as multiplying by 1/2. So again, distribute through, and you still get the 4, 3. Okay? So that's really all there is to multiplying and dividing vectors. It's just simply distributive property. With multiplication, you just distribute your number in front through, your scalar, you just distribute it through. For division, you just take A, divide it by the number you're dividing by, and then you take B, divide it by that number, and boom, you got your new vector. All right. There are a couple rules, though, I want to go over real quick. Okay, there's a few rules I want to go over real quick. The first one is vector u plus vector v is the same thing as vector v plus vector u. Okay, I didn't put a tail on the other one. Let me take the tail off of this one. Okay, vector u plus vector v is the same thing as vector v plus vector u. Okay, now vector u plus vector v plus vector w in this form is the same thing as vector u plus vector v plus vector w. Okay, so just like addition, this is commutative or associative as well. You can do it in any order you want. Parentheses don't matter. All right, parentheses don't matter. And a vector plus 0 is simply that same vector. Okay, a vector plus 0 is simply that same vector. Also, if you have some scalar, remember a scalar is just a number. If you have some scalar times vector u plus vector v, and of course these could be any letters, I'm just picking u and v. Okay, that's the same thing as that number times vector u plus that same number times vector v. Alright, that's all there is to the rules of adding vectors. Okay, it's associative, commutative, you can use distributive property, just like you could with regular addition, regular distributive property. You can do the same thing with vectors. Okay. Last topic we're going to hit is magnitude. I kind of alluded to magnitude a little bit yesterday, or today in class, because you should be watching this afternoon. All right, so magnitude. All magnitude is how long is the vector. How long is the vector? That's all magnitude is. Okay, the symbol for magnitude is simply a double absolute value sign. So this right here represents the magnitude of vector v. Okay, so that's all that's how you write the magnitude of a vector. It's kind of like a double absolute value symbol. Okay, double absolute value. All right, that is what the symbol is. Now the formula for magnitude. If we wanted the magnitude of vector a comma b, it is simply the square root of a squared plus b squared. Okay, it is simply the square root of a squared plus b squared. And if you notice, this looks a lot like the Pythagorean theorem. Why? Well, that's because it is. Say this was vector a plus b. I mean vector ab, I'm sorry, not a plus b. Say this was vector a comma b. Well, if you made a right triangle out of this, oops. If you made a right triangle out of this, let me see how straight I can draw this line. Not very. Okay. All right. A is simply your left or right distance. B is simply your vertical distance, up or down. So here we made a right triangle, and the vector is simply the hypotenuse of the right triangle. So the square root of a squared plus b squared is your formula for magnitude. All right, let's look at a quick problem. And this will be the last thing I do, and we'll call this video done. Let's take the absolute value of vector 3, 4. Well, this is simply going to equal the square root of 3 squared plus 4 squared, which is simply the square root of 9 plus 16. 9 plus 16 is 25. So the square root of 25 is 5. All right. So that is our magnitude. Of 3, 4, our magnitude is 5. Okay? So that's it for your vector addition, subtraction, multiplication, and how to find the magnitude of a vector. You can feel free to watch this video as many times as you need to. Make sure you come to class tomorrow ready to work some problems. See you tomorrow.